Hi, good morning students. This is me, your Renjith sir. And today we are going to start a new chapter, force and laws of motion. In our previous class, previous chapter, we were studied a lot of things about motion. Motion, uniform motion, non-uniform motions, equations of motion, graphical representation of motion. All about the motion we were studied in our last class. But we are not yet studied what is the real cause of the motion. What is the real cause of motion? Can you anybody answer it? Can you say the answer? What is the real? So, for example, while I am pushing this pedestrian, it is move. How it is move? So I am applying what apply? I am applying a force. So a push, pull, hitting, kicking, everything. This all activities, the object is moving from one place to another place. So this is called what we applied. That time we applied force. So actually, what is force? We can in science, force is the reason of motion of a body. What is force? Force actually a push or a pull. A push or a pull is known as force. So we can push an object, that object is moved forward, and pull. When we kick a football, that football is going, and when we hit an object, that is changes its position. So in all cases, force is needed to object move. So what is the real cause of motion? It is due to the force. So actually we can describe as force is a push or a pull. Simply we can say that force, define what is force. Define force means force is a push or a pull. Okay, so force is a vector quantity. Force is a vector quantity because I am applying the force. They have a certain magnitude and the object is moving along with that the direction of force. So force is a vector quantity means it have magnitude and direction. Force is a vector quantity because it have both magnitude and direction. So force is not a scalar, it is a vector quantity. So when we apply force, what effects are happened after the applying force? For example, when a ball is kept in stationary position, I am applying a hit or a pull or push on a ball. The ball is moving somewhat distance. So when we apply force, the object where is in rest, that changes its state. They are starting moving. So what are the effects of force? We are discussing the effects of force. First one, force can change a state of rest or a motion. Force is when we apply force, when an object is in stationary, we apply a force, that object is start moving. So stationary object start moving. So changing the state of the object. So then when a ball is fastly coming ball, we can apply a force to stop it. So force can also used for can stop the moving object. Force can use to stop the moving object. Force can use to stop the moving object. Force can use to start the moving object when they are in stationary. Force can use to stop the moving object when the object is in moving. We can apply a force. That object can stop. Then what other effect? Sometimes you can see the batsman hit a ball. Using their batman hit the ball is in another direction. From bowler bowling in certain direction, batsman hit into another direction. So batsman applies force. That force, another effect of force is force can change the direction of the object. Force can change the direction of object. Force can change the direction. Then another effect is we can press an object. Here is the duster. I am pressing that duster. What happened? Its shape is changing. So that another effect. I am pressing the duster. That shape is changed. So when we apply force, another effect is changes. It can change the force can change the shape of the object. So these are the effects of force. When we apply force, a stationary object can move and can to stop the moving object. When force can apply, it stop the moving object, can change the direction of the object and can change the shape of the object. This is the effects of force. So what is force? Force is nothing but it is a push or a pull, and simply we can apply force is responsible to object move. The force can responsible for stationary object can change their motion, and the moving object can stop and change in the direction and change in the shape of the object. Okay, right. Then next is balanced and unbalanced force. That is very important thing. Balanced and unbalanced force. Balanced and unbalanced force. Have you seen any time in the tug of war? Have you seen it? Sometimes the tug of war that the two teams are pulling the tug in opposite direction. For example, here is an object. So one boy is applying a force into this direction. Another boy is applying force in that direction with the same force. The same force with the opposite direction. Does it move? This object is move. Does this object move? No, it does not move because the force is equal and opposite direction. Force is equal and opposite. That means net force. Here is this direction and here is another direction. For example, I am pulling this table into my side, and another guy is pulling that table into opposite direction. Two are applying same force. Does this move? This table does not move because the force is equal and opposite force. Net force is F is equal to 0. Here net force acts as 0. So it does not move. This type of motion is called balanced force. This type of force is called balanced force. So here one boy is pulled more force with that boy. Consider to that boy. This side is more force is applied. Where it is more, where is the more force? That direction the object is moved. So that is what is called unbalanced force, not balanced force. I am applying here, this is the example. This stand, I am applying more force to this direction compared to other side person. This stand is coming here. Okay, that way this stand is moved. So that is what is called the unbalanced force. So what we conclude, a unbalanced force is needed for a motion. Object need a motion, and applied unbalanced force is essential. So wherever the unbalanced force, that object only move. That means unbalanced force means net force not equal to 0. F is not equal to 0 is called unbalanced force. The object move in the direction of which force is most, or which direction, which force applied most, that direction that object is moved. So force, when an object moving, an unbalanced force is needed. For example, we are pushing a car in the outside. There is an unbalanced force. Force is pushed in the direction of car is moved. So we can apply an unbalanced force. A motion unbalanced force is very essential. So first law, there are Newton's derived 3 laws of motion. From before the Newton come to the laws of motion, derive the laws of motion, there is an interesting experiment done by Galileo Galilei. Galileo Galilei explained the motion about the object, about the motion. He make two planes. He make inclined planes. This type of inclined planes without this. Okay, this type of inclined plane, and a ball is not a ball. It is a here in your textbook there is a marble roll. Marble ball is rolling here, and that ball is come to this much height. And again, that ball is it is a frictionless plane. It is very smooth plane. That inclined plane. That ball is come back and come to this position again. Then this continues that it will never stop, because this plane is inclined plane is. Then Galileo changing the inclination of the plane. There are then little this here, and they are the angle of the plane surface is decreases. Then the ball is rolling much more height than in the first experiment. Then here little more longer. Then in the parallel line, in the horizontal, it is continuously move. So in the practical situation, it is very difficult to prove this type of motion, because every object has it a resistance. Every plane there is a resistance, because when we kick a football, no other force is applied, but after a few distance go, after it stops, because the surface, the ground has some friction. That friction is used for friction is opposes the motion of the object. So every surface there is a friction. So friction means it is resisted due to the motion of the object. Friction resists due to the motion of the object. So every surface there is friction. So without friction, this ball is continuously going and going and going and going. Okay, so there is a friction. So in this idea, Newton established 3 laws of motion. That is what is called the Newton's laws of motion. Then Newton studied these Galileo's ideas of motion of the object, and Newton presented 3 laws of motion. That is first law, second law, and third law. The first law of motion, we are going to study the first law of motion. That is described as every object in the universe. Every object remains its state of rest or uniform motion unless it is compelled by an external force acted upon it. That was the first law of motion. I repeat, every object remains in the state of rest or uniform motion unless it is compelled by an external force acted upon it. ഒരു അൺബാലൻസ്ഡ് ഫോഴ്സ് അപ്ലൈ ചെയ്യാത്തിടത്തോളം കാലം ഒരു ഒബ്ജക്റ്റ് അതിൻ്റെ റെസ്റ്റിലോ നേർരേഖയിലുള്ള ചലനത്തിലോ അല്ലെങ്കിൽ മോഷനിലോ തുടർന്നുകൊണ്ടിരിക്കും എന്നാണ് ഈ ലോസ് പറയുന്നത്. എവരി ഒബ്ജക്റ്റ് അറ്റ് റെസ്റ്റ് ഓർ യൂണിഫോം മോഷൻ, സ്റ്റേറ്റ് ഓഫ് റെസ്റ്റ് അറ്റ് യൂണിഫോം മോഷൻ unless compelled by an applied unbalanced force acted upon it. Okay, that means it is another name of this law is called the law of inertia. Law of inertia. This is called another name of first law. That means it is the laziness, like you. Laziness means whenever you are in when a body is in rest, it have the tendency to remains its rest. Whenever the moving body have the tendency to continue its motion. റെസ്റ്റ് ഇരിക്കുന്ന ഒരു ഒബ്ജക്റ്റിന് ആ റെസ്റ്റിൽ തന്നെ തുടരാനുള്ള ടെൻഡൻസിയും മൂവ് ചെയ്യുന്ന ഒരു ഒബ്ജക്റ്റിന് ആ മൂവ്മെന്റിൽ തുടരാനുള്ള ടെൻഡൻസിയും അതിനുണ്ട്. അതിനെ പെട്ടെന്നൊരു മൂവ്മെന്റ്, ഐ വിൽ ഗീവ് സം എക്സാമ്പിൾസ്. ഓക്കെ, സോ ഫോർ വി ആർ ട്രാവലിംഗ് എ ബസ്. Bus is moving in a constant speed, or bus is moving in speed. We are sitting or standing, whether we are inside the bus. The driver applies the brake in the bus. Fastly, driver applies brake. What happened? We are moving forward. Why do it happen? Bus is in motion. We are also have the tendency to move along with the bus. We are also in the motion. Then suddenly the rest. Suddenly brake applied, bus is come to the rest, but we have the tendency to continue its motion. So that is what is we are moving forward. Our body is have the tendency to continue its motion. So it is called the inertia of motion. Or another example, one vehicle is rest. So bus is the same case. Bus that is in rest, we are standing, but suddenly bus is start on moving. Bus is moving. What happened to us? We are moving backward because our leg is with the motion, but our upper part of the body is still in the rest. So we are in rest. We have the tendency to continue its rest. So bus is sudden move, we can fall backward because our forward body part is not that motion. The body has the tendency to continue its state of rest. So we are in backward. Okay, that is the inertia. Inertia means where the body have the tendency to continue its state of rest or uniform motion. The body, every body in the universe have the tendency to continue its rest or uniform motion. That is what is called the first law of motion. Another name, law of inertia or laziness. Every object have the laziness. അതായത് റെസ്റ്റിലിരിക്കുന്ന ഒബ്ജക്റ്റിന് മൂവ് ചെയ്യാനുള്ള മടി, അല്ലെങ്കിൽ ആ റഷിൽ തന്നെ തുടരാനുള്ള ടെൻഡൻസി. മൂവ് ചെയ്യുന്ന ഒബ്ജക്റ്റിന് അത് സ്റ്റോപ്പ് ആകാനുള്ള മടി, അല്ലെങ്കിൽ അത് സ്റ്റോപ്പ് ആകാനുള്ള ടെൻഡൻസി വളരെ കുറവാണ്. മൂവ് ചെയ്തുകൊണ്ടിരിക്കാനാണ് ടെൻഡൻസി കൂടുതൽ. അതുകൊണ്ടാണ് നമ്മൾ അതിനെ ലോ ഓഫ് ഇനേർഷ്യ എന്ന് പറയുന്നത്. ഓക്കെ, so there is a lot of examples in your textbook. Activity 9.1 to explain the law of so one more example, I can say one more example. When a motor car makes a sharp turn at a high speed, ഒരു സ്ട്രെയിറ്റ് ലൈനിൽ മൂവ് ചെയ്തുകൊണ്ടിരുന്ന ഒരു കാർ പെട്ടെന്നൊരു ടേൺ, ഒരു കർവ് വളയുമ്പോൾ നമുക്ക് സ്ട്രെയിറ്റ് ലൈനിൽ തന്നെ പോകാനുള്ള ടെൻഡൻസിയാണ് നമ്മുടെ ബോഡിക്കുള്ളത്. പക്ഷെ കാറ് ടേൺ ചെയ്ത് കഴിയുമ്പോൾ നമ്മൾ ഓട്ടോമാറ്റിക്കായിട്ട് സീറ്റിൽ നിന്നും അങ്ങ് മറിയുന്നു. കാരണം നമ്മുടെ ബോഡി ആ ചേഞ്ചിനെ റെസിസ്റ്റ് ചെയ്യുന്നു. അതുകൊണ്ടാണ് നമ്മൾ പെട്ടെന്ന് ഒരു ടേൺ ചെയ്യുമ്പോൾ നമുക്ക് നമുക്ക് സ്ട്രെയിറ്റ് ലൈനിൽ കണ്ടിന്യൂ ചെയ്യാനുള്ള ടെൻഡൻസി ആണല്ലോ. പെട്ടെന്നൊരു വളവെടുക്കുമ്പോൾ നമ്മൾ വീഴാൻ പോകുന്നതിൻ്റെ കാരണം ഇറ്റ്സ് ഇനേർഷ്യയാണ്. ഓക്കെ, we can read. We tend to get thrown to one side. This can again be explained on the basis of law of inertia. We tend to continue in our straight line motion when an unbalanced force is applied by the engine to change the direction of motion of a motor car. We slip into one side of the seat due to the inertia of our body. അപ്പോൾ നമ്മൾ ഒരു റെസ്റ്റ് ഇരിക്കുന്ന ഒബ്ജക്റ്റ് പെട്ടെന്ന് സ്റ്റാർട്ട് ചെയ്യുമ്പോൾ നമ്മൾ പുറകോട്ട് പോകുന്നതും, ഒരു വാഹനത്തിൽ ഇരിക്കുമ്പോൾ പുറകോട്ട് പോകുന്നതും, നമ്മൾ while we are driving we can use seat belt because when we apply brake we have the tendency to റെസിസ്റ്റ് ദ ചേഞ്ച്. ആ ചേഞ്ചിനെ റെസിസ്റ്റ് ചെയ്യുന്നു. അതുകൊണ്ട് നമ്മൾ മുമ്പോട്ട് പോകാനുള്ള ടെൻഡൻസി, നമുക്ക് ആക്സിഡന്റ് ഉണ്ടാകാനുള്ള ടെൻഡൻസി ഉള്ളതുകൊണ്ട് നമ്മൾ സീറ്റ് ബെൽറ്റ് ഒക്കെ ഇടണം എന്ന് പറയുന്നത്. ഓക്കെ, ഇതെല്ലാം എന്ത് കാരണമാണ്? ഫസ്റ്റ് ലോ അല്ലെങ്കിൽ ലോ ഓഫ് inertia. Every object an object remains in the state of rest or uniform motion unless an applied unbalanced force acted upon it. ഒരു applied unbalanced force ആക്ട് ചെയ്തില്ലെങ്കിൽ ആ റെസ്റ്റിലും യൂണിഫോം മോഷനിലും കണ്ടിന്യൂ ചെയ്യാനുള്ള ടെൻഡൻസിയാണ് ഫസ്റ്റ് ലോ ഓഫ് മോഷൻ എക്സ്പ്ലെയിൻ ചെയ്യുന്നത്. സോ കം ടു ദി ടെക്സ്റ്റ് ബുക്ക്, പേജ് നമ്പർ 117. Activity 9.1. Lot of examples there. Activity 9.1. Look at your textbook and you read with me. Make a pile to similar carom coin on the table. Attempt a sharp horizontal hit at the bottom of the pile using another carom coin or a striker. If the hit is strong enough, the bottom coin moves out quickly. Once the lowest coin is removed, the inertia of other coins make the fall vertically on the table. These this activity is very familiar to us because when we play the carom coin, we can make a pile on the carom coin and we can use a striker to strike fastly on the bottom of the coin. That bottom coin only move, that other all coins stay in their rest. The all coin, that is what is called the inertia, because other all piles have the tendency to continue its state of rest. That apply unbalance, which one is get unbalanced force? The bottom coin. That bottom coin only move forward. Understand? So next activity, another very important activity you can do from your home. Set a 5 rupee coin on the stiff card covering an empty glass tumbler standing on the table as shown in figure 9.7. You can see the figure 9.7. Give a card a sharp horizontal flick with the finger. If we do too fast, then the card shoot away, allowing the coin to fall vertically into the glass tumbler due to its inertia. Take a glass and a cardboard is placed over it, and a 5 rupee coin is on the card, and fastly flick a card, and the 5 rupee coin come inside the glass. This is very interesting, so you can do it because the 5 rupee coin have the tendency to continue rest. So that is what it is falls down to the glass. Okay, so activity 3. Place a water filled tumbler on a tray. Hold this tray and turn around as fast as you can. Observe what water spills. Why? So observe that grooves proved the saucer of the placing the teacup. It prevent the cup from the toppling over the case of sudden jerks. These all activities are the examples of inertia of motion. So first law, I repeat, first law. What is first law of motion? An object remains in state of rest or uniform motion unless it is an applied unbalanced force acted upon it. So you have to study very carefully what is law of inertia, what is first law of motion, then examples, lot of examples there. What is unbalanced and balanced force? So example examples of balanced and unbalanced force. So I am winding up here. Read your textbook very carefully and study this all. First law. Next class we are going to study second law and third law. Okay, thank you.